Hello friends, welcome to my channel. So today we are again here to discuss the network topics, right? As you know, earlier we discussed the basic of networks. In the basic of networks, we discussed about the network, like what is the network and what are the network devices like switches, router, access points, wireless controllers, IP phones, and some other stuffs, right? We also discussed the end user device like laptop, like barcode readers, our phones, handheld devices, and this. We also learned what is the network topology. That means how physically we can connect our devices with each other. We also discussed about the centralized device, like if we are having only two computers, then how we will connect our devices. If we are having more than two computers or more than two devices and want to create a network, then we require a device like centralized device, that is switch. We can also use hub, but due to some restrictions or drawbacks, as we discussed in last classes, we are not using the hub. So now today we will discuss about the network topology architecture. Architecture means we have already discussed that what is the network and how can we create the network. What? Now, before going to the further concept, we have to know about the network topology architecture. That how we can design our network, how we can structure our network. So basically network architecture means it defines the structures of your network, how you will connect network devices to get the target, to achieve the target. Means it totally depends on the requirement of your organization, right? Suppose you are a network architecture in a company, you are a network administrator or a designer in a company, right? And you want to design a network for your organization. So first thing is that you have to understand the network requirement, that how many end user device you need to connect in your network environment. Other, which kind of services you require in your network. You require only a simple network to get access the networks, or you require some kind of filtering, some kind of security, some kind of restrictions also, right? Whenever you will understand these kind of things, easily you can structure your network. So today in the topic of network architecture, we will learn what kind of network architectures are available in the network. Like if there are different organizations, few organizations are very small, few are very large, few are using the mixed network architecture. So we will learn that, right? So network architecture means it defines the structures and the interaction of your devices in your network, or you can say it will let you know how you can connect the devices to achieve your target into your network, right? Now, so there are a lot of network architectures are available. Like first is three-tier network architecture, and next two-tier network architecture, spine leaf architecture, WAN architecture, SOHO architecture, and cloud architecture. Three-tier architecture means it is having three layers in your network. Means we design the network in three categories, or you can say we use three categories devices in our network so that we can design three-tier network in our environment. In two-tier network environment, we only use two kind of devices, or we only create two layers in our network environment. Spine leaf architecture is used basically in the data center structure. Whenever you will use the data center, then we will design our network in the form of spine and leaf. For WAN architecture, you can say the WAN technologies, we use the WAN architecture. For SOHO means small office, home office. If you are having a small office, or you are having a small setup at your home, then we use SOHO setup, SOHO architecture. Cloud architecture means, as you know, in nowadays, most of the services are migrated toward the clouds like Google Clouds, Azure, AWS, and some other clouds. So we will also discuss how cloud architecture works. So now we will discuss first architecture, that is three-tier architecture. So three-tier architecture is having three layers: core layer, distribution layer, and access layer. What is the access layer? Access layer basically is a layer where we connects the end user. Means on the basic layer, on the access layer, we connects the devices. Which devices? Suppose this is the access layer and this is the first layer, or you can say layer where we directly connect our laptops, or we directly connects our machines, we directly connects our servers here. So this is the access layer. Access layer is the basic layer of our network where we connect the devices or we connect the end user directly. It basically, the function or the purpose of this layer is to provide the connectivity to the end user devices, provide the VLAN kind of configuration, provide the loop avoidance mechanism by the help of STP or something. So, and these hardware, because if we are defining our architecture on the basis of layer, that means they are having some different. So in the hardware perspective, they are having a different hardware. If we will talk about the access layer hardware, these switches are having low performance, and these are also in low in the cost, right? Because suppose if you are having 1000 user or 1000 end user device in your LAN environment, then accordingly you require multiple switches at your network environment. So it is not possible to purchase high end devices for to connecting the end user, right? It will totally impact your IT budget. So that is the reason, or it is another reason we use the access layer switches, or we can say we use access switches at access layer to connect the end user device. So the function of access layer is that we use the access layer to connect the end user devices directly. End user device means it can be your laptop, it can be your PC, it can be your access point. Suppose this is your access point. It can be your IP phone. So it totally depends on your network requirement. Sometimes it can be your server also. Suppose if you are having any server in your environment, so it can be your server. So end user device can be connect on the access layer, right? Now, distribution layer. Distribution layer means it provide the redundancy to access layer. Means it provides you the redundant connection. Redundant connection means suppose this is your access switch and these are two distribution switch. So that means this access switch is having two connections. One connection is first distribution switch and another connection with second distribution switch, so that the connectivity will be available in any condition. Suppose in any condition this switch goes down, that means end users will not lose the connectivity. Why? Because they are having a redundant path via the second switch and they can move later or they can move here, right? So why this form, it provide the redundancy. And next thing, distribution layer is also provide the routing. Sometimes we do the routing at distribution layer. So these are the higher end series switches, and they also having the higher performance than the access switches, and they are also is in higher in cost compared than the access switches. Next thing, we also can do security mechanism over here. Like we can do the filtering on distribution layer, we can apply the route maps to do some filtering at distribution layer. So the security features or the filtering we can do at distribution layer. We can also do the security things at access layer, but only the port security. right? We can apply the port security at access layer. What is the port security? We will learn later. What? Yes, we can do the port security here on the access layer, right? So basic difference, what is basic difference in access and distribution layer? Distribution layer is provides redundancy. These are the higher end switches. These are the high throughput switches. These provide high performance and also provide the redundancy to our network environment, and we can do the filtering over here. Now, next layer is the core layer. This is more higher performance switches or routers compared than the distribution layer. This is also called the backbone layer. Backbone layer means here we are having a ISP, right? So ISP connection will directly connect with these devices. So all the traffic those we are having from here will communicate or will go via these devices. That is the reason these devices are having high traffic. So these devices must be the higher end devices so that they can handle such kind of traffic, right? They are basically the routers. Those are directly connected with ISP, and we perform the routing over here. It is advisable that don't do the filtering over here in three-tier network architecture. So this is basically the three-tier architecture. In the large organizations, if your organization is large, we use such kind of architecture, right? Here you can easily check access layer is the lower layer of three-tier architecture. It is the closest layer of the end user. So it is a closest layer to the end user, right? In access layer, we can network access policy, layer 2 security mechanism like port security. We can use loop prevention mechanism like STP, RSTP, and another important most used technology at this layer is Vlan. So basically access layer is responsible to connect the end user directly. So next, distribution layer. Distribution layer is the middle layer of three-tier network architecture, right? And it is the aggregation layer of the access switches. Multi-layer switches are used in distribution, means we are not using access switches here because we require high performance switches at here. So that is the reason we use MLS, means multi-layer switches. There are two types of switches, L2 switches and L3 switches. L2 switches means those can do only the switching. They can't perform the routing. What L3 devices can perform the routing. Basically, router is a L3 device that can perform the routing. What? In nowadays, we are having some MLS, means multi-layer switches. MLS means multi-layer switches. Those are having the capabilities of both layer 2 and layer 3, means few switches can perform both the functions. Means you can create the VLAN over there, that means they are able to perform the L2 activities. You can attach the device over here. These suppose this is a MLS switch, you can create any VLAN here and you can assign this port as a access in a VLAN. That means it is having a layer 2 capabilities. And now if it is connected with a router or with another switch and you want to perform the routing between two devices, if this switch is MLS multi-layer switch, then it is possible. You can enable the routing over here. Suppose you want to perform the BGP here and you want to perform the BGP here, right? Then it's possible if your switch is the L3 or you can say MLS switch, multi-layer switch. So it is advisable that please use distribution layer as a MLS switch, right? Next, core layer is the backbone layer. That is basically is the upper layer of distribution, and we directly connect the ISP over here. And routing protocols are used at this layer, right? So I think this is the clear cut topology for three type. It is basically used in large organization. Now, what is the two-tier architecture? Two-tier architecture is also the same. Only one thing we are not using here. We are not using distribution layer over here. Suppose your organization doesn't want to use such kind of hardware. They don't want to utilize such kind of devices. They don't want to invest such money in this architecture. Then you are having an option of two-tier architecture. That means the work that you were doing on the distribution, you will do on core layer. What we were doing on the distribution, we were doing the redundancy, we were doing the filtering, we were doing the routing. So all the steps will be taken care by the core layer, right? So depends on your organization requirement, you can design two-tier network architecture again. On access layer, the purpose or the work of the access layer will be same, and user device will be connected over here directly on the access switches, right? And the other functions like the redundancy and the routing or filtering will be performed by the core switches. And all the access layer, core layer and distribution layer will having a different capabilities hardware, depends on your requirement, right? Next thing, suppose these are the access switches. So there are different model in the access switch, depends on the requirement. What kind of requirement, let me explain. Suppose in our organization you are having only desktop users or laptop user. That means you can simply use a normal switch, L2 switch, like 2960 or 2960X or 2950, that is the legacy one, right? Such kind of switches you can use, right? In nowadays, yeah, we are using 9300 watt. Suppose you are having only the desktop user or wide user, you can say you are having only the wide user, those are using printers, those are using laptop, and those are using desktop. In such kind of scenario, you can use simple switch. What? In some cases, we require PoE switch. What is the PoE switch? PoE switch means power over Ethernet. Means you are having these switches. Suppose this is a 24-port switches, right? And you are having some devices like you are having some PCs in your environment. So you have connected via wire, and PC is having power, external power, right? You are having some APs, right? Like this, and you are also having some IP phone at your environment. Suppose you are having a IP phone, this is IP phone connected here, right? And this is like this. So this kind of devices, AP and IP phone, requires a power. To providing the additional power adapter over here, where is an option that we can connect these devices with the switch. If switch is power over Ethernet capability, means if switch is having the PoE capability, switch can provide the power with these Ethernet cables only. If you are having Ethernet cable, if we connected the Ethernet cable to the switch towards the access point or towards the IP phone, it will provide the power also. So you don't require a additional power adapter to connect these kind of devices. So on the level of access switch, it depends on your requirement, what kind of devices, yeah, what kind of end user devices are available in your environment. Accordingly, you can select your switch whether it is PoE enabled or not. Because if you will purchase the PoE enabled, definitely it will be costly than the simple one. So it is also the part of your design, right? Next thing, now I think you are aware what is the PoE switch, power over Ethernet. Some devices require the power. Now other option is that suppose you are having thousands of user in your network environment, then you require multiple switches to connect the end user devices like this. Suppose this is the 48 switches, 48 port switches, so we require like this, we can connect 48 devices, 48 wide devices or end user device on these switches. Here and also on these. What we will do, we can connect the devices and we require to configure all these switches one by one, right? I require ports. I can connect the PCs over here. I can connect the PCs over here, right? And as per the requirement, I need to configure this switch. I need to configure this switch and I need to configure this switch. Can we avoid this kind of configuration? Can we avoid this kind of circumstances and can achieve the available ports? Yes, there is another option in which we can do it. What is that option? That is called stack. Basically, stack provides you the port density. Port density means in the form of a stack. What stack says you are having multiple switches, those are having the capability of stack. Again, you have to decide whether you require a normal switch or you require a stack switch. Suppose I'm having three switches. These are three switches, right? And the model of these switches are 3850, right? 3850, I'm having three switches and I want to connect users on these switches. So what I will do, I will connect all these switches in the stack. What is the stack? They are having a special cable connectivity that is called stack. How stack will work? Stack will work in the cross connectivity. The first switch will connect with this switch will connect with this, and this switch will connect this. This is the cross connectivity, right? It's like this we can connect the switches with each other. Now, whenever these all switches are in stack, that means physically they are having three switches, but logically it is a single switch. It will work on a by a single switch, as a single switch, right? So what will be the benefit to use the stack? So whenever you will do the configuration on the active switch or on the primary switch, the configuration will be applicable on all three devices, right? Logically these will work as a single switch with the help of stack. So you are getting a required port. What the control plane is only the single. It is providing the single control plane. The management thinks you will do via the active one. Of how can we decide which one is the active one? So all the switches are having priority, right? All the switches are having priority. So higher priority will become the active one. This priority value is 1 to 15. It is always advisable that if you want to make this switch as a active, then please define the priority of the switch as 15 and the other switch must be having the lower than it. That means they can have 14 or 13 or other than that. What the active switch must be having the higher. Next thing, sometimes in the production environment, we do one mistake. Suppose we are already having a stack in which three switches are working. Now, our requirement is to connect another switch in this stack. Then what you will do? These switches are already in stack and this is under the production. Suppose you just connected the cross connection, means stack connection, with the existing stack. Sometimes we see if active one not having the higher priority. Suppose we decided the priority like this: 10, 9 and 8. What? Why mistake? If you not change the priority of this switch and it is having the priority of 15 and you put this switch in the production, what will do? It will override the configuration of all the switch and it will create a outage in your network. Why? Because it is having the higher priority. Once you will put this switch into your stack, it will become active. Whenever it will become active, all the member switches will sync the configuration with the active, and because this is the new switch and it is not having any kind of configuration, then these will also not having any kind of configuration. So it is always advisable that please, whenever you require to put a stack switch in your production environment, then please check the priority of all the existing stack switches, and please put this stack switches priority accordingly. Means it must be lower than the active one, right? So this is the LAN architecture, 3-tier architecture, 2-tier architecture. Now, what is a spine leaf architecture? Basically, spine leaf architecture we use in data center. What is the data center? As you know, data center means where we are having a lot of servers, storage or something, right? These are called the data center. These are not the actual LAN environment where end users are connected. Suppose you are using some services like Facebook, like Google. So these companies are having separate data center because they are having a lot of services over there and a lot of server over there, so they placed into the data center. In data center architecture, they also design such kind of things like spine or leaf like a access layer. On the LAN architecture, on access layer we connect directly users or end user device on the access layer. Here on the leaf layer we connect the switches, servers, or you can say the end devices at the leaf, right? Leaf layer is having the access devices like switch, servers as routers and some other devices, right? Spine layer is like a core layer. In the LAN environment we use is the core layer for routing. Here we are having the spine. Spine layer is responsible to providing the routing to all over data center, all over network. So in data center environment, we are having spine and leaf architecture. Whenever we will cover the data center part, then we will discuss what kind of spine switches, what the work of leaf switches, how we can configure the spine and leaf. So this is the spine and leaf architecture that is basically used in the case of data center. Now, next one is small office and home office network. So if you are having a small setup at your home or at your network, then we don't need to invest such money to create a 3-tier or 2-tier architecture. We simply require a connectivity so that we can connect the network and we can use our requirement. So in this architecture, this is the Soho architecture. Suppose this is a ISP. We simply purchase a connection, internet connection from the ISP, right? And we put a router over here that will perform the routing, simple routing, right? And then we will directly place some switches over here and we will connect the network devices, sorry, end user device over here. What is the end user device? Like our laptop, like our desktop, like our printer or some other device that is required at your environment, right? So this kind of setup is called Soho environment, in which you are not using core or distribution layer. You are just using a router to connect with the ISP or to providing you the routing, and then directly you are using the access switch to connecting the end user devices. This is the access switch and it is providing you the end user device. So this kind of setup is called Soho setup, Soho architecture, small office and home office architecture. Sometimes you also require some kind of access point, right? Suppose you don't want to use such kind of, like, you don't want to use such kind of switch to connecting the device, then what will you do? If you remember, like in your home environment we use the broadband, and what is the function? Suppose it is the Airtel ISP and you are having a connection with Airtel, then what Airtel will do? Airtel will provide you a device and that is having the capability. Which capability? It is having 4 Ethernet port, so that if you require, you can do the wide connection. It is also having the access point capability, means it will also provide you the wireless connection, right? This is simple your home office connection, right? And the home office, you use only a single device. Sometimes we called it DSL router, sometimes we also called like modem, right? So it, or some kind we call broadband router. So this router will provide you the functionality of all three devices, all these three devices. Like it will work as a router to provide the routing so that you can reach the ISP. It will also provide 4-port switch, so that if you require, you can connect some byte devices like desktop, like printer, like your TV or something, or your cameras. IP cameras also works on, you can say, on the switch. And it can also provide you the access point feasibility, so that the wireless machines, your phones or other machines, can connect with this, right? So this is the small office and home office architecture. So it totally depends what is your requirement. Next, cloud architecture. As you know, in nowadays we are using cloud. Cloud means that we are using virtualization. We are using the services or our servers on VMs, right? So there are two types of cloud: private cloud or public cloud. Private cloud is also called the on-premises cloud. That means your organization or the large organization is managing is on setup, on virtualization setup, on data center cloud setup. So that is called the private cloud. Another setup is you can purchase or you can take the services on rent. Why? Some public vendors, public cloud vendors like AWS, like Azure, like Google Cloud. So there are two types of cloud architecture. One is private, another one is the public cloud. So this is basically the discussion about the network topology architecture. Like how can you design a network in your environment? Suppose you are having, let me do one thing, let me design 3-tier architecture over here, right? So that it will be easy to you to understand. Suppose we are having packet tracer. Here we need a 3-tier architecture. What you will do, on the core layer you will place two routers to provide you a redundancy. This is router A and this is router 2. And at the end of distribution layer, we will place MLS, multi-layer switch. I told you multi-layer switch. So I use multi-layer switch over here. Now we require access switches. Access switches can be at any model like 2950, 2950 or 2960. Access switches can be vary on the basis of your requirement, like how many end user devices you need to connect, like this, right? So we are just designing a 3-tier architecture. How you will do? Suppose we are connecting this router with our MLS and this MLS with this, so that it can provide you a redundancy. In any case, if this router goes faulty or the link goes fail, it is having the redundant connection. In the same manner, this is also having a redundant connectivity towards what the routers, right? So this is the basic functionality of our distribution layer. And core layer basically provides the connectivity towards the ISP, right? So it is connecting with the ISP. Suppose it is the cloud. Cloud means it is a ISP connection. So it is having connection with cloud, or you can say internet, or it is also having with internet. Now next thing is that suppose it is having connection with first distribution switch and also having a redundant connection with second distribution switch, so that all the end users will having the redundancy. In the same manner, you can design your network so that you will provide the redundancy to your end user devices. So like this we can design our 3-tier network architecture. If like this, each switch is having two connection with the distribution switch, right? What the distribution switch are having connection towards all the access switch, right? So like this approach, you can create three-tier architecture. Suppose you are connecting a machine over here, a machine over here. You are connecting some server over here. You are also connecting few phones over here. You connecting some IP phone over here. You are also connecting some wireless tablet over here. Some smart devices means your phone or something. So these are the wire device, so they will require a wire connection like this, right? These all are the end user devices. We require a POU port for this, so it will not support, right? These are the smart devices. So smart devices is collect via the wireless. If you want, we can use a wireless devices also. Suppose I'm using a wireless hub. I'm also using some wireless devices like the access point or something. Suppose this is a access point, and access point must be connected with the switch, and like this. Whenever I connected the access point, these devices automatically connected with wireless device. What wireless device must be connected with switch? That means access point must be connected with the switch. This is your smartphone. Smartphone will not connected with the switch or the wide connection. These will connect with the help of your access point, right? So like this, you can design your network as per your requirement. This is basically the function of network architecture, to create a blueprint of your network. If you are having a blueprint of your network, you are having a roadmap of your network, you can easily achieve your target. So I think you guys understand what is the network architecture. So my motive was to discuss the network architecture in today's class. So guys and friends, if you think that this video or this topic is helpful for you to understand the network architecture, then please like this video and subscribe the channel. Thank you. Bye bye. Take care.